Cool. So, sorry about the delay there. So what we're going to do today is build a full stack GraphQL application and deploy it. So what we're going to do is start off using Neo4j AuraDB, which is Neo4j graph database in the cloud. And then we're going to see how we can build a GraphQL API to expose that data that we have in Neo4j Aura. And then on the front end, we're going to build a React application with Next.js. So that is the plan. We'll also see how to deploy that using Vercel. So we're not going to build a super complicated application. It'll be fairly kind of bare bones, looking at displaying news articles, but mostly to show how the pieces fit together, how we can use these different technologies together. So my name is Will. I work on the developer relations team at Neo4j, and you can find me online at lionwj.com or on Twitter as well. Great. So here's the outline. There's roughly 4 modules. We're going to start off using Neo4j AuraDB. We'll see how to import some data. We'll do a little bit of working with Cypher. Then we're going to see how to build a GraphQL API using the Neo4j GraphQL Library. Then we'll take a little look at Next.js, which is a React framework, and how we can actually add our GraphQL server and the React client application in Next.js, and then we'll deploy that with Vercel. So you can definitely follow along. We have little hands-on exercises with this icon here. So when we see that in the slides, we'll stop for a few minutes to give folks a chance to follow along with what we're doing. We are going to use a few different online services. So we'll be using Neo4j AuraDB, we'll be using GitHub, and we'll be using Vercel. If you don't have accounts set up with these, that's fine. It should be pretty easy to create those quickly as we go through. And most importantly, we're using the free tier of all of these. So you don't need to put in a credit card and worry about getting unnecessary charges. We're using free tier for all these services. But I think it's handy to actually use these services to see how they work and actually get hands-on with them. So that's the plan. We've got 2 hours today to do that. So we should have our basic application up running and deployed at the end of the workshop today. Cool, so let's jump right into our first section, which is working with Neo4j AuraDB. And our goal is going to be to spin up a Neo4j instance in Aura and load some data using Cypher and take a look at the Cypher query language to write some basic queries, which we'll then use later on in our GraphQL API. So if you're not familiar with Neo4j, Neo4j is a graph database. And I should say, if all these different tools and technologies that we're using today, if you're new to all of those, that's totally fine. We're going to be starting at kind of a basic level and working our way up for all of these. So if you're not familiar with GraphQL or Neo4j or Next.js, don't be intimidated. That should be fine. We're going to start with a nice starter app that should get us up and running. So Neo4j, like I said, Neo4j is a graph database. If you've worked with other databases, you may be familiar with like tables and relational databases and SQL, or document databases like Mongo that use documents and collections for the data model. So Neo4j uses graphs for the data model, which we'll talk about what a graph is in a minute. And we use a query language called Cypher. You can see an example of Cypher up here in the upper right of the screen. You can think of Cypher as kind of like SQL, but for graphs. So Cypher is very much about declarative pattern matching. So we kind of draw the pattern that we're looking for, the pattern that we want to work with in the graph in this sort of ASCII art notation. And then the database figures out the best way to actually interact with or find, search for that data. So this query, this 3-line query, you can see we're drawing this ASCII art representation of this graph pattern where we're looking for addresses that have an incoming relationship on this registered address. You can see we're drawing that as kind of like an arrow. So nodes or the entities we represent within parentheses, kind of like drawing a circle. Then we have this registered address relationship that's connected to an officer, that's then connected to an entity. This data set, this query comes from the Pandora Papers or Panama Papers data set, which was this data set of offshore legal entities that a data journalism group called the ICIJ, they use Neo4j to analyze this data. So this query is saying, find anyone with an address in New York and what offshore legal entities are they connected to. So there are lots of interesting things we can do with graph databases, things like graph analytics, data visualization. We talked about Neo4j AuraDB, which is Neo4j database as a service that we'll take a look at in a minute. And then there is a GraphQL integration for Neo4j that we'll be using, the Neo4j GraphQL Library. So really, there's this platform around sort of the core Neo4j database. And this is just some of the examples of different tooling that's available. But I think this is good to have an idea of what are the different sort of use cases and tooling, what are people doing with Neo4j, what can you do with it? And I think of this as kind of like this spectrum between data science and analytics on the right, and more sort of transactional operational workloads on the left. And of course, you can combine these two. It's really kind of the spectrum, but there's showing some of the tooling that is more relevant. So for example, if we're doing graph analytics with something like the Neo4j Graph Data Science Library, maybe we're interested in machine learning with graphs. Visualization is probably more relevant there. On the left side of the spectrum, which is where we're going to be today, where we're building more of a transactional full stack application. We want to build an API layer. So some of the drivers and API tooling are going to be more relevant for us. In this case, we're using the GraphQL integration. So you can see there's lots of different tooling integrations and use cases for Neo4j. But let's jump right in and set up our Neo4j Aura instance. So we're going to navigate to Neo4j Aura, and we're going to sign in and start up a Neo4j AuraDB free tier database. So anyone can sign in and create a database. There's kind of 3 steps here, which I think we'll sort of zoom in a little bit. So the first thing, dev.neo4j.com/aura-login, or just go to neo4j.com/aura. And once you sign in, you can sign in with Google or create an account with email and password. Then you'll see this screen to create a database. You want to select AuraDB free, give it a name, and then be sure to select that we're going to load or create our own data. We don't need to start with the beginner data set. Once we do that, we'll get a pop-up that has our random password. We definitely want to be sure that we copy this and save this somewhere, because we will need it later on to interact with the database. And then we'll see something like this in the console app that says, hey, we are provisioning your database And once it's running, it takes a couple minutes to spin up, then we'll get this green running indicator here with the connection URI. So this is the connection string for our Aura instance. So that's another important thing that we want to copy and save for later, because we'll need to use that to create a connection to Neo4j Aura from our GraphQL API. So I'm going to go ahead and do this. Let's go to neo4j.com/Aura. And let's zoom in a little bit so we can see this. Now I have kind of a wonky monitor setup here. Okay, so we're going to start free. And oh, looks like I was already signed in, but you'll be prompted to sign in. And then the first time you sign in, it walks you through that create database flow directly. But I'm going to click create database. I want AuraDB free. Let's call this the full stack GraphQL workshop database. You can choose different regions. I'll choose the default, that's fine. And then I want to load or create my own data. And we'll click create database. And here's where I need to copy the password. I'm going to save that somewhere off screen. And say, yes, I have stored those. Let's continue. And it'll take a couple of minutes to spin up. So let's pause here for a couple of minutes. And if you're following along, go ahead and follow along until you get to this screen. I'll put the steps up again. Right here.
And if if people are wondering if they can use Sandbox, that's a yes. So if you already have an AuraDB free instance you're using for something and you don't want to delete everything you have in there, you can spin up a Sandbox in this case.
Yeah, Sandbox works as well. Aura is nice because the Aura free tier instances stick around. So if I have a side project or a hobby project with Sandbox, those databases go away after a few days, but the Aura databases, those stick around, so I can come back to those or run a side project off Aura. But otherwise, yeah, I think everything should work. Everything we're going to do today should work with Sandbox. Okay, so while we're waiting for our Aura instance to provision, let's talk a little bit about the graph model, so that we're all on the same page. This may be a refresh for some folks, maybe new for others, but just so that we're all on the same page. And then we'll talk a bit about the data set that we're going to use today. So we've said graph a few times now. And so when we're talking about graphs in the context of Neo4j and graph databases, we're talking about the data structure. So nodes, these are the entities, the objects in our data model, and relationships connect exactly to nodes. Every relationship has a direction. Nodes have labels. So in this case, every node is just labeled node, which is not very helpful. But we can think of labels as a way to group nodes, tell us what type of thing that they are. Relationships have a single type. So here they're all just labeled as relationship, which again is not very helpful. When it comes to storing properties or attributes, we can store arbitrary key value pair properties on either the node, or the relationship. And these are the basic components of what's called the property graph model. So another term that you may hear a lot is knowledge graph. And a knowledge graph, I think, is really just an instance of a property graph. So where we have some actual data, but we're putting things in context, right? So in this case, we have some data about news articles. We know the topic of the articles. We know the people that are mentioned in the article. We know the geo region that it's about. So now we have some context of what these articles are, what the topics are, because we have the connections in the graph. So that is the idea of a knowledge graph, really just an instance of a property graph, I think, that helps put things in context. And the data we're going to work with today is what I like to call the news graph. This is real data from the New York Times API that has exactly what we were looking at on the previous screen. So we have every day, I think, pull in the top articles, and then we have some information about each article, like what are the topics of the article? Is it about certain people? Are there certain organizations like companies or countries? Is there a specific geo region it's about, like a city, state, country, etc. There's a few examples, and I've used this data set a few times. You can find more information about it, including how to set up sort of a daily import in this GitHub repo that's linked down here. And you will just need to create a API key to fetch data from the New York Times API. But we're going to work with just a slice of this data. So we don't need to worry about that for today. Just this is the data model that we're going to work with. Okay, so we're at the next hands-on section. And so what we're going to do now that we've all provisioned our Neo4j Aura instance, we're going to open up Neo4j browser, which is like a query workbench for Neo4j. It allows us to write Cypher queries and visualize and work with the results. So we're going to do that to load some data about news articles. And then we're going to write a couple of Cypher queries and see how Cypher works. So let's switch over to our Neo4j Aura instance. And I'm going to go to open with. So you should now see something like this in the Neo4j Aura console. Let me zoom in a little bit. Something like this, where we have some information about the database that we created. Now it's running, and I have my connection string, so I'm going to copy that as well and set that aside. So we'll need the connection string and then also the generated password from earlier. So we'll go to now open with Neo4j browser. And I'll need that password from earlier that we were shown when we started to provision our Aura instance. So we'll paste that password in there. And now we are connected. I'm going to close this slide out here. This has some sort of how to use Neo4j browser information. So I'm going to close that. And what did our instructions say to do? Run :play news graph. So we'll run that :play news graph. And we should see this browser guide. So this is a browser guide, this sort of carousel view that has embedded queries that we can click on to load the queries. If you've never seen Neo4j browser before, basically, we have one frame, one of these frames, to write a Cypher query and visualize the results. So if I say something like match A, return count A, this query, this is just saying match on all of the nodes. So nodes we define with parentheses, find all the nodes, and then return the count of the nodes. And of course, we get 0 because we just created a new fresh database. So that's the basic interaction that we have is one of these frames per query and results. Now this browser guide, this is just a way of kind of embedding some content to make workshops like these easier. Anyone can build these. This is just some HTML, but it's helpful in our case to share queries, and we're going to have some exercises in here as well. So the first thing we're going to do is load some data because we have no data in the database. And we're going to do that using APOC load JSON. So APOC is like the standard library for Neo4j and Cypher. So it has some added functionality for doing lots of different things, in this case for loading data from JSON files. So this query says call APOC load JSON and then some URL. This is just pointing out to a JSON file in a GitHub repo that has just a snippet of the data from the New York Times API for articles. And then we're just returning this. So APOC load JSON is going to parse this JSON file and give us just the results of what that JSON file looks like. So we have an array of what results, and then we can see for each object in here is an article, and these are all coming from the New York Times. We have things like the title, the abstract of the article, the URL, the geo region, and some other meta information. We haven't created any data in the database yet. That's what this next query is going to do. So go ahead and click on this query. So this is the third slide where it says data import. So click on that, and let's go ahead and run this. Then we'll talk about what this query is doing. So we should get back a little graph visualization like this. And we can see the article nodes that we added. And if we double click, we can expand. So here's an article about the best movies of 2021. We have the two authors of the article. It has two topics, 2021 and movies. It specifically mentions Benedict Cumberbatch. We can see other articles that are also about movies. So we can see this graph data that we've now created. If we look at this query, and I'll hit escape to go in kind of full screen mode, what we've done is loaded this JSON file. We're unwinding over the results array. So remember, this results array is an array of objects where each object was an article. And then for each of these articles, we're creating some data in the graph. So merge, this is a command that allows us to create data without creating duplicates. And you can see we're grabbing the values from the JSON object in our articles array that we're iterating over. And then for each topic and person, we're creating those relationships. So if we have people in this is the person facet array, then we're going to create those relationships to connect those people to the article. And we basically just do that for all of the metadata that we have about the article to create the nodes, and create the relationships that exist. And you can see some of this, we have to do some string manipulation and so on, but I think in most cases that works out. So that's our basic data import query. So go ahead and run this on your Neo4j Aura instance, and you should have some sample article data loaded. And again, to get there, I just ran this :play newsgraph command, and that brought up the browser guide with these embedded queries. And I clicked on this data import query to bring that into the query editor, and then I hit this run command. Okay, anyone having issues with that? We'll pause for just a minute to let everyone catch up here. Make sure you run this data import command and that you see some graph data that is returned. Okay, well, let's take a look at how we can query this data using Cypher. So we've said a few times that Cypher is this pattern matching language where we draw these ASCII art representations of the graph pattern that we want to work with. So here we have a pretty simple pattern. We're saying match. So match is a search command. So find where this pattern exists in the graph. And we want to match on nodes. So nodes we surround with parentheses to sort of draw this circle representation. And then :article, that is the label. So match on nodes with the label article. Every node can have one or more labels. Ours just have a single label. So we have, and we can see what labels we have in the database. If we click on this slide out, we have articles, authors, geos, like geo regions, organization, person, photo, and topic. We can also see the relationships we have that connect those. In this simple one, we're saying find every node that has the label article and bind those nodes to the variable A. So that's the thing before the colon. And then A becomes a variable that we can refer to throughout our query. So here we're going to just return those nodes. And we should see here are the article nodes that we've created. And we can click on them or hover on them to see the properties. If we double click, we'll sort of expand a little bit. And this article, this is kind of separate on its own. But again, if we go back to the movies, we can see well, what are other articles that are also about movies. And we can sort of traverse the graph this way, sort of double clicking our way through, but we can also create more complex patterns. Here we are adding ordering and a limit 10 to just get the 10 most recent articles. So that's something we can do, but we can also create more complex graph patterns. So here we are saying match, so find article nodes, but now also traverse out to find the topic nodes connected to those articles and return everything, but give us the most recent articles and 25 of these paths. So now we can see, because we've included the topics in that pattern in the Cypher query, we get those returned as well. And we can create arbitrarily complex patterns Do we have more complex ones? Let's modify this one. So article has topic, and then we can also return maybe other articles that have those same topics. So now we're returning a bit more in our query, and we can see the overlapping topics among articles here. Cool. One thing that is really powerful with Cypher and that we can do in Neo4j is this idea of the shortest path and variable length paths. So here we've taken this variable length path operator. Oh, and it's complaining because I don't have an upper bound on it. We'll put an upper bound on it just to make the warning go away. But basically what this pattern says, because we have this asterisk in our relationship piece of the pattern, that means find these two nodes. So find the topic cheese and the organization TikTok, and find the connection between these two nodes following an arbitrary number of paths. And in this case, we put an upper bound on that to 9. So up to 9 relationships. So that's what this piece means. Just find where that pattern exists. And if we included this in a match, we would get all of the different ways that these two nodes are connected. But oftentimes we're interested in just what is the shortest path, so the fewest number of relationships between them. We can wrap that in the shortest path Cypher function. It's going to find the shortest path connecting cheese and TikTok. What do we end up with? An article about cream cheese that's about New York City, connected to an article about New York that's about COVID, all the way through to an article about TikTok. So you can see these sort of interesting paths that can come about when we use shortest path. And shortest path can be super useful for things like routing, or for things like recommendations, and so on, which we'll take a look at in a minute here. Okay, so that's a super brief whirlwind introduction to Cypher. A good resource for Cypher is the Cypher ref card. So if you just Google Cypher ref card, you can find this reference document, which I'll drop a link to this in the chat, that has lots of the different functionality of Cypher with lots of examples. So that's a handy resource to have up. But what we're going to do now, so we have one Cypher exercise. We'll pause here for a couple of minutes. And so what we want to do is, assuming that we've found an article, so we're just going to take some article, some arbitrary article. In our news application, we may want to recommend other similar articles to users. So if you are done reading this article, what are other similar articles that you might be interested in? So what we want to do is start with this skeleton query and think of, okay, well, what is sort of the graph traversal that we could use to find other similar articles and return those. So let's use this basic skeleton pattern and fill in here what you think would be a good pattern for finding other similar articles. When you get that working, we're going to save this query and we'll see how we can use this in our GraphQL API in a few minutes. But let's pause here for a couple of minutes, give everyone a chance to write hands-on with Cypher, your article recommendation query. If you have a good one or something clever, feel free to share it in the chat. But we'll pause for just a minute or so.
Maybe while everybody types, well, I don't want to distract everybody, but there's one question came in from chat. If there is a difference, you can name between Neo4j Aura, Neo4j Sandbox, and Neo4j Desktop while using GraphQL. Is there any that would come to mind?
Any differences between the three?
Yes.
Yeah. So there's lots of different ways to sort of get Neo4j. So Neo4j Desktop, Neo4j Sandbox, Neo4j Aura. Those are common. There's also a Docker image that's a fairly common way to get at Neo4j to run it. Neo4j Sandbox and Neo4j Aura, those are going to be hosted Neo4j instances. So those are going to live in the cloud somewhere, managed by someone other than you. Sandbox is really good for just that initial trial experience. So Sandbox comes loaded with a bunch of different data sets. And in the context of GraphQL, if you go to the code tab, there's a tab in Sandbox that has code samples. Several of the Sandbox use cases have a full GraphQL example. So if you're looking for a Neo4j GraphQL example, you can look in Sandbox and see code there. Aura is meant for projects that I'm actively working on, development, ready to sort of get to push to production. And there's a free tier of Aura that is really helpful because those stick around and aren't shut down like Sandbox is. And when using GraphQL, you can use either of those. I think you'll have similar features in either. The nice thing about Sandbox and Aura is that it's hosted in the cloud. So if I'm ready to deploy an application that is going to also be running in the cloud, they can talk to each other. If I'm using Neo4j Desktop, the Neo4j is running locally on my machine. I can do the same sort of development and testing. But when I'm ready to deploy something, even if it's a test application, that's just running on my machine. And if I have, like we're going to be using Vercel with Next.js, if I'm using desktop, when I go to deploy it to Vercel, well, Vercel can't talk to my local machine if I'm running desktop. So that's a case where I might want to think about using Sandbox or Aura when I'm ready to start sort of deploying things and using with other cloud services.
Okay, cool. Thank you, Will.
Cool. So did everyone get their recommendation query? Let's look at a simple one that we could have. So I guess one way we could approach this would be to look at our data model. So if I do call db.schema.visualization, and then I'm going to do a colon style reset so I can see all my captions there. So here's the data model. This call db schema visualization, this kind of inspects the data that I have in the database. So if I'm not sure what data I'm working with, I can run that and I can see this sort of meta model of the data that I have. So I have articles, I have authors, photos, topics, persons, geos, organizations. So I think a simple query might be just to look for articles that have common topics. So if I've read an article about, I don't know, hiking, maybe I want to read other articles about hiking. That might be a good way to start. So for my query, we're going to say, here's the article that I found, and then I want to find the topics for this article. And then I'm going to follow incoming has topic relationship to other articles, which I'm going to call rec. So these rec articles, these are going to have one or more topics in common with the article I'm trying to generate recommendations for, and I'm going to return those recommended nodes. And if let's return star here so we can actually see what this looks like in the graph. Oh, we need the T too. Here we go. So if you see what I did there, at first I was returning star. I didn't have any relationships because I wasn't returning the topic. So I just gave that a alias T. Now we're returning everything. So, okay, what do we have? We have an original article. I'm not sure which one was the original. We can look in our table to see. The original was this one about New York City. So this was our original one. It has 3 topics, and we found these other articles that have similar topics. So these other purple ones, these are our recommended articles because they share similar topics. So that's a fairly basic one. We could also do things like compute a score and order those by score. So if you're overlapping in all 3, you'd be scored higher. I don't think any of these overlap on all 3. So we get just this one that overlaps on 2 topics, and so on. But we can also bring in some graph data science, lots of interesting things we could do there. But okay, so I'm gonna copy this query and put it somewhere else because we're going to see how we can use this functionality, this idea of writing queries in Cypher, how we can use that with GraphQL in a minute. Okay, cool. So hopefully everyone was able to get their Aura instance running, load the data set, this news data set, and play around with Cypher a little bit. So now we have our database with our news articles. In our case, we loaded them from JSON, but imagine we have maybe some other ETL process that is loading this data. And as part of building our full stack application, we want to end up with like a React application that some user can use to view the day's news articles, say, for example. And we don't want to just expose our database publicly to the client application. We want to build some API layer that sits between the database and the client, and that will allow us to do things like configure what data we're exposing. Maybe we want to add some authorization functionality. Maybe we want to implement some caching layer, something like that. Is typically what we do at the API layer, and why we don't want to just expose our database directly to the client. And GraphQL is a common way to build that API layer. So let's talk a little bit about GraphQL if you're not familiar with GraphQL. And again, if you are familiar with GraphQL, this will be a quick review. So GraphQL is a technology for building APIs. GraphQL is really a specification for a query language and a runtime for fulfilling those queries against an API. So we have a strict type system. So we define what data is available in the GraphQL API, and then at query time, the client constructs a GraphQL query that's really a traversal of this data graph. So in our type definitions, where we're defining the types that are available in GraphQL, we're also defining how those types are connected by relationships. That's where the graph part of GraphQL comes in. So then at query time, the query is a traversal through that data graph where the client can request exactly the data that it wants to be sent back. Here's an example of GraphQL type definitions where we have defined 3 types: movie, genre, actor, and then the fields on each of these types. You can see that we define the type of each field, which can either be a scalar, like a string, an integer, or can be a relationship connecting to another type. So in this case, genres is connecting a movie to one or more genre types. And that bracket, that means that's an array field. So specifically an object array field, since genre is an object. So we can be connected to multiple genres. Here's an example of a query. We have an entry point for the query. By default, these are fields on the query type. So there are a couple of special types in our GraphQL type definitions, the query and the mutation. And we can have arguments in our, in this case, entry point. So here we are searching for movies where the title is A River Runs Through It. And then the rest of our GraphQL query is what's called the selection set. So a selection set is this nested object that is, I guess, doing two things. One, it's defining the fields that we want to be returned in the GraphQL request. And then it's also defining the traversal through the data graph. So because of the nested structure here, so we start from this movie, A River Runs Through It. And then if we look at the directors, for example, we're traversing to the directors and then grabbing the name field of the director, so who directed A River Runs Through It. But then we're also traversing out from those directors to find 3 other movies that they directed. So I like to think of a selection set as a traversal through this data graph, as well as specifying the fields to be returned by our query. The selection set defines the shape of the response. So on the right, that's our result of this GraphQL query, comes back as a JSON document, but you can see the structure of it, structure of the JSON response exactly matches the selection set. So the client at query time is free to construct exactly the data that it wants. And because of the type safety in GraphQL, we know that exactly the shape and type of the data that is coming back. So that's for querying a GraphQL API. On the back end, how do we implement the logic for fetching data for GraphQL requests? Well, in GraphQL, we have this concept of resolvers or resolver functions. So every field and every type in the GraphQL server has a function that defines how to resolve or how to go to the data layer to find that data. Here's an example of what this might look like. This is using an ORM kind of syntax where we're calling out to a database through an ORM. This comes from an application that was looking at conference talks. Conference talks are in a room, they have a theme, and then we have recommended conference talks. And so we can see, starting off, we're searching for sessions with some search string. So imagine I have a web application, I'm searching for, I'm gonna show me all the GraphQL talks at this conference. We're gonna execute this first resolver function to go out and match any sessions by whatever search term we type in. But then depending on what fields are requested in the selection set, we then may need to make another request to the database. If we ask for the room, we need to go back to the database, and for any sessions that matched our search term, well, what room is that in? Same for theme, and the same if we request recommended sessions. So these resolvers, these are called in a nested manner. So you can see a problem right away is that because we're going back to the database multiple times, we're making multiple round trips from our GraphQL server application to the database, and that's going to be kind of slow. So that's kind of one of the first sort of performance-related issues we typically run into when we build GraphQL APIs. We're going to use today the Neo4j GraphQL library. And that problem goes away because the Neo4j GraphQL library generates these resolver functions for us. So we're not actually going to write any resolver functions today. These are all going to be generated for us. And actually, the Neo4j GraphQL library is actually going to generate a single database request for any of our arbitrary GraphQL requests. And that may sound like something reasonable, but that's actually extremely powerful because it addresses this nested resolver it's called the n+1 query problem. So anyway, just wanted to point out this idea of resolver functions. This is kind of the I don't know, basic way of building GraphQL APIs, writing these resolver functions, which can be a little bit boilerplate and then have some performance issues. So I just wanted to point out that concept. GraphQL has some advantages. We talked about this idea of the client being able to specify exactly the data that the client wants. And typically this is matched to a component or like a view in your application, which is nice because that means that you can have that data fetching logic can live with that component, that view in your application, and exactly the data needed to render the component, to render the view, can be requested in a single request. So one round trip and only sending exactly the data that's needed, which is nice for performance, but also I think has some developer productivity benefits as well. There are, of course, some common challenges in the world of GraphQL. I think a lot of these come up from a lot of the well understood practices from the REST world don't always nicely apply in GraphQL. So things like HTTP status codes, error handling, and caching. These are done a bit differently in the GraphQL world. So those may be some of the things that come up. Also, we talked about this n+1 query problem, where because of the nested way that resolver functions are called, we don't want to be sending multiple requests to the data layer for our GraphQL operations. So we need to think of how to address that as we are building our GraphQL API. And as we said, fortunately, the Neo4j GraphQL library solves that problem for us by generating database queries. One thing that's really nice about the GraphQL ecosystem is the tooling. So the developer tooling around GraphQL. A lot of this tooling is driven by GraphQL's introspection feature. So this means that once we have a GraphQL server, GraphQL API application running, we can introspect the types. We can ask that GraphQL server to tell us what types, what data is available. And then we can use that to construct tooling that allows us to generate things like documentation to see all of the data that's available in the GraphQL API, things like autocomplete as we're constructing queries, query validation, these kinds of things. So we're going to use a tool called GraphQL Playground today, which is this in-browser tool for querying and exploring GraphQL APIs. There are similar tools. Graphical is a similar tool. Also, Apollo, I think it's called Apollo Sandbox, which is part of Apollo Studio. You'll also see similar functionality. But today we're going to use Playground. So, okay, here's our next hands-on exercise. And what we want to do is open up this URL. Let me drop that in the chat. So this is a GraphQL server that's out there. So we want to open up this URL, and this will take us to GraphQL Playground for this GraphQL API, and let's explore the Docs tab to see what kind of data is available, and then let's run a couple GraphQL queries. So this is very similar to the GraphQL API of articles and topics that we're going to be building. So let's take a look at how we can query that. Here, this way I have a wide monitor here. Let's see if we can have these side by side so we can see what we're supposed to be doing and what it looks like at the same time. Cool. So I'll pause here for a couple minutes to give folks a chance. So this is the Docs tab that we want to look at. So the queries, these are the entry points for the API. And we'll want to write some queries. So I'll pause here, give folks a few minutes to query the API, see if you can query this for the most recent articles, see if you can find articles connected to topics you may be interested in. But just a chance to get familiar with how to construct GraphQL queries.
Yeah, maybe maybe I can jump in quickly here. No immediate questions, but if you know, if you want to give us a quick update on your status in chat, let us know. Ping us, so we can see how it's going for you, how it's working. Can you follow along? And again, if you have any questions about this, don't be shy. Type it in chat.
Okay, so I'll go through this. So like I said, the Docs tab, this is really useful to find the entry points to the API, first of all. So we see all of the query fields. And for the write operations, if we had those in this API, we would have another type here called mutations. This is just a read-only API, so we only have the query fields, but we can see right away that we have articles, and we can see the fields available on articles. And then we also have things like aggregations for each type, and we have similar entry points for the other fields like authors, topics, people, organizations, and so on, and how those are connected. So let's run our first query here, which is just giving me the first 10 articles. Let me zoom out a little bit so we can see the data we get. Cool, great. Here's our data, and we can add more fields. If I do command space, I get autocomplete, which is quite nice. So I can traverse out to other articles that are in the same topic, perhaps. And so now I'm getting the most recent 10, And then for each topic connected to those articles, here are other articles that have that same topic. Quite nice. Here's our second query, oops, where we're looking at what's it, topics. So just starting from a different entry point. So topics, and here we're going to use the where. So where allows us to filter. So we're going to filter where the topic is movies. And let's bring the name of the topic and then all articles connected to movies as well. And again, I can use autocomplete, control tab or control space rather, to add more fields, and I can even do other traversals as well if I wanted to find, maybe for all of these articles, also what organizations are they connected to, and so on. Most of these are not. Oh, here's one connected to an art gallery. Here's an article about Netflix, and so on. Okay, cool. So we can see how to construct our GraphQL queries. So we're going to now build a GraphQL API very similar to this one that we've just been exploring. And as you can see in the URL for this, with this vercel.app domain, we're going to deploy it to Vercel. Let's talk a bit about how to build GraphQL API applications and how specifically using the Neo4j GraphQL library to do that. So we've said that we're very much talking about the API layer that sits between our client application, which in this case is going to be a React application, and the database. So we don't want our client application querying the database directly. We're building this API layer that sits between the client and the database. So we can do things like control what data is exposed, add authorization, this kind of thing. So let's talk about the goals and the basic features of the Neo4j GraphQL library, and then we're going to clone down a GitHub repository and take a look at some coding. So the first goal of the Neo4j GraphQL library is really this idea of GraphQL first development, where the GraphQL type definitions are used to drive not only the GraphQL API, but also the data model for the database. So we define the type definitions in GraphQL and use that to define the property graph model that we use in the database. We can do that because the graph data model in GraphQL is very similar to the property graph data model. Once we do that, then the Neo4j GraphQL library is going to generate a GraphQL schema based on the types that we've defined, but it's going to include a lot of functionality in a generated API. So we saw all of the query field entry points that are added. We saw that where argument that allows us to do filtering. We can do sorting, pagination. We're adding all of the database specific types like date time, the point spatial types, these kinds of things as well. So we don't have to define all of that in our type definitions. That is generated for us automatically. And then at query time, any arbitrary GraphQL request is translated to Cypher, and importantly to a single Cypher query. So that means for any arbitrarily complex GraphQL operation, we're generating a single database query that's sent in one operation, so one round trip to the database. The database can then figure out how best to optimize that, figure out where that pattern exists in the graph, and send that data back to our GraphQL application. So there's two things that are going on here. One is that means we don't have to write any data fetching logic as a developer. So we don't have to write these resolver functions. And then that solves the n+1 query problem where we're not sending multiple requests to the data layer. We're just sending one query to the database. So that's how we can handle basic CRUD, create, read, update, delete functionality. Basically, the Neo4j GraphQL library generates create, read, update, delete operations for each type that we define by default. We can configure some of that. But what about adding custom logic? So if we have some business logic or something specific that we want in our application, how do we add that? Well, one way to do that is with the Cypher GraphQL schema directive. I think this is one of my most favorite features of the Neo4j GraphQL library, and I think really something that really stands out. And this is basically the ability to annotate our GraphQL type definitions with a Cypher query so that the custom Cypher query that we've defined is then executed when we're resolving that field. So basically what this means is that we can expose the arbitrary power of Cypher through GraphQL. So without writing any resolvers and still fitting into that single database query for each GraphQL request framework, we can add custom logic. So schema directives are GraphQL's sort of built-in extension mechanism that says, hey, there's some custom logic that should happen here. So this is on the schema on the type definition side. So the consumer of the GraphQL API doesn't see this. It's only the developer setting up the GraphQL API. So in this example, we have a recommended field that is returning businesses. And so we're traversing through business reviews to find recommended businesses for, I guess, for a specific user. I think this is a recommended field on the user type. So let's look at an example, sort of the bare bones, how to get started with Neo4j GraphQL. So the Neo4j GraphQL library is a JavaScript library for building Node.js GraphQL APIs. So we're going to install the Neo4j GraphQL package, the GraphQL reference implementation is a peer dependency, and we're also installing the Neo4j JavaScript driver. So the Neo4j drivers we use to create connections to Neo4j in various languages. Here we're using JavaScript. And then we pull in Apollo server, which is a nice JavaScript GraphQL server, but we can use the Neo4j GraphQL library with any JavaScript GraphQL implementation. Apollo server happens to be easy to use. I think it's kind of the default for JavaScript. And here's sort of the basic minimal snippet. Let's move through these. So basically, we import the Neo4j GraphQL class, the Neo4j driver, and Apollo server. We define our type definitions. You can see these are pretty basic. We have two types, movie and genre. The only thing we haven't seen before is this relationship schema directive. So I said earlier that we use the type definitions to drive the data model, not only of the API, but also of the database. Now, the property graph model has a bit more information than the GraphQL data model. Specifically, we saw that every relationship has a direction and a type. So the relationship directive here allows us to specify the direction and the type of the relationship. So this allows us to stick to the naming conventions that are typically used in the property graph model for relationships. We use this uppercase uppercasing for relationship types, but in GraphQL, we typically use like camel case for field names. So this allows us to call the field genres and stick with the GraphQL convention, but use the all uppercase in genre convention for our property graph model. So we define our type definitions. We then create a connection to the database with the Neo4j driver. When we instantiate the Neo4j GraphQL class, we pass it our type definitions and the driver instance, and then we just pass that schema through to Apollo server and start our Apollo server instance. So notice we didn't have to write any resolver functions, any data fetching code. That's all generated and handled for us by the Neo4j GraphQL library. And so then that gives us a GraphQL API that we can then start to query and create data. So we saw that we basically get an entry point for each type that we declare. And we can add additional fields. As we add additional fields, those are included in the generated Cypher query. I'm going to skip through. This is kind of an overview of some of the basic types of queries that are available, which I think I'll kind of skip over a bit. Just pointing out that we can do two different kinds of pagination. We can do this, this sort of offset pagination, where we give a limit and offset and paginate that way, or we can do cursor-based pagination using the relay style connection types. Those are generated for us as well. We saw the where argument and some of the filtering that we can do. So we can filter for things like, in this case, we have a book API, so where the price is less than a certain amount, or we can search for, in this case, we're filtering based on some date. We can also filter based on geodistance. So if we have point types, we can search for things within radius of a point. We can use these filters across relationships, which is really quite nice as well, just by using nesting in the where argument. Okay, cool. So if we go back to the data model that we have created for our article, our news graph, we can think of the type definitions to drive that model. So we have the type article, the fields on article, including the relationship fields that connect them. I've also added the exclude directive here, which excludes the create, update, and delete operations from being created. So this will give us basically just a read-only API. Now there's a couple of ways that we can create type definitions and that we can then use to drive our Neo4j database through the Neo4j GraphQL library. And I guess it kind of depends if we are starting a new application and we want to use that to drive the data model in Neo4j, or if we have an existing Neo4j instance. So I like to use this tool, arrows. So arrows.app. Arrows is a diagramming tool that allows us to define and create diagrams for property graphs. We can export the model that we create as GraphQL type definitions. So in the export tab, I have a bunch of different options like download the image, JSON, whatever, but I can also generate GraphQL type definitions. So if we're already using arrows to create our property graph diagrams for our data model, we can use that to generate our GraphQL type definitions. Or we can also actually generate the type definitions from an existing Neo4j database, which is described in the docs here, this introspector, which I'll drop a link to that in the docs or in the chat, and that's the docs as well, which is going to be useful for us. I think you saw the live stream that we did last week, or no, 2 weeks ago. We covered using the introspector to generate type defs from an existing database. But we've already gone through that process using arrows when we created our data model. So we have that created for us already. Okay, so normally what we would do now is create our GraphQL API application using the Neo4j GraphQL library. But I'm actually going to skip ahead and talk about Next.js because we're actually going to build our GraphQL server as part of a Next.js application using the API routes feature of Next.js. So if you're not familiar with Next.js, that's okay. We're going to start with a little skeleton example in a minute. But let's talk about Next.js and then take a look at some code to get this working. So Next.js is a framework for React, or a meta framework, I guess, something that's built on top of React that includes a lot of functionality that isn't really bundled with React out of the box, but is typically useful. So if you're not familiar with React, it's a JavaScript library for building client applications, for building UIs, for building web apps, typically. Next.js adds things like file-based routing. So to create a new route in our application, we just create a new file, server-side rendering, and one thing that we're going to take advantage of is server-side API routes. So what we're going to do is pull down some code from GitHub and be sure that you click use the template for this repo. I'll drop the link in the chat here. Oops, did I get the right link? This link. Yeah, so that links to our GitHub repo. And what we want to do is click on use this template. So what we're going to do is create a new GitHub repository using this initial one as a template, but then that will be a repo on your own GitHub account that we're then going to connect to Vercel to deploy it. So I'm going to click use this template, and we'll call it anything we want. Let's call this full stack GraphQL workshop. And you can either do public or private. Doesn't matter. I'll do public, create repository. So if you haven't seen this template feature on GitHub, it's quite nice because it allows us to generate a repository from an existing one. But now you'll have a GitHub repo under your own GitHub user based on this template repository. And so I don't have to worry about like cloning it and then creating a new repo and pushing it up. You keep all the commit history too, which is quite nice. So then what I want to do is clone this repository that I just created. Oh, already exists. And I already have one called that in that directory, so I'll just put it in a new directory. Called this full stack GraphQL workshop, and then I'm going to open this up in a code editor. And let's get both windows on the screen here so we can see what we're doing. Okay, cool. And so if we look at the repo, and look either on GitHub or in a code editor, we'll see here's that news.json file. This is the file that we pulled in earlier, and our import Cypher commands that we used. And then we have this Next.js directory. And this is where our Next.js application lives. Cool. So let's follow along the rest here, and then we'll pause for a couple minutes for folks to follow along. So step one was open the repo in GitHub. Click use this template to create a new one. You want to clone the repo. And then the next step is to update this .env.local file in Next.js directory. So let's look at that. And here we are setting some environment variables. Now, what I want to do is update the value of these environment variables, not to point at this server, which I think is probably no longer there. You'll probably get an error if you try to use that one. But instead, what I want to do is fill in the connection credentials for this Neo4j Aura instance that we created earlier. So I'm going to use my values, but this you'll want to fill in your values for this. So the Neo4j URI is going to be this connection string from the Aura console. So we'll grab that. And then the user, by default, that's going to be Neo4j. And the password, that was randomly generated. So I'll grab my password for my Aura instance. And we'll save that. And then the next step it says is open up a terminal. And in the Next.js directory, we're going to do an npm install. And that'll take a minute to install our dependencies for the Next.js project. And then we're going to do npm run dev. And this is going to start our Next.js app by default on port 3000. So we should be able to go to localhost 3000 to open this up, and we should see very basic welcome to Next.js application. So this is the default application that we get when we create a new Next.js app. So if you're following along, I'll pause here and then we'll take a look at the code. If you're following along, let's go through these steps to create a template repository and clone that, then update the .env.local file with the connection credentials for your Neo4j Aura instance. So this is what mine looks like. Yours will be a bit different. And then run npm install and npm run dev in the Next.js directory. And you should see a basic app like this. So I'll pause for a couple minutes to give folks a chance to get caught up there, and then make this a bit bigger so folks can see, and then we'll take a look at the code and see what's going on. Definitely, if you have any issues, shout out in the chat and we'll try to get those resolved.
Exactly. There's one question in chat came in. How would you, or I don't know if this is it's, beyond the scope of this session, but if you showed some filtering, if you want to use and or filters in addition to that, is that something we are going over a little bit later, or can we show that how to do that? I think you're muted. Now you're back.
Yeah, that's a good one. So we can do that using our example. What was that? Newsgraph.vercel.app. Yeah, there we go. So if let's start over here. Topics will be our entry point. Where, and so if I do the control space, so the where argument takes a topic where input object, which I see here, and I can go in the docs and I can search for topic where to see the fields that are available on it, or I can just kind of control space to see what all of my options are. And if we look at kind of the top level, we have an or and an and. So I could do an or, and then this is now going to take another topic where, so I can say name movies. I think this is actually going to be an array, so this logic gets wrapped. What's another topic that we had in the graph? Let's take a look. Don't want coronavirus topics. Let's find something more fun than that. Sure, like gun control. Have a very varied query here. But okay, so we're searching for where the topic name is movies or gun control, and so this or is like an outer wrap where those two get wrapped, and so we then apply that, and you can see where the topics we get movies and we get gun control. So I can do that with or, I can do that with and at that sort of top level. Yeah, good question. Yeah, and the filters are quite powerful. If you look in the docs, do we have the docs? Docs here. If you look in the docs, queries, filtering, there's a section on filtering in the docs that goes through a lot of the different options that we have for filtering. Cool. Did everyone get these steps to clone or to use the template repo to create your own, bring it down and update your .env file? We've got about 20 minutes left, so I'm gonna press on here so that we can get through, but definitely let us know in the chat if you have any issues, and we'll try to get that resolved. So I guess before we start talking about Vercel, let's take a look at the code here. So do a quick walkthrough. So we said we have some data that we used earlier in this Next.js directory. We have first of all package.json. So it's always helpful, I think, to see what dependencies we're pulling in, and there's a few already that we're starting with. So Apollo client, we saw Apollo server earlier, Apollo Client is a tool for querying GraphQL APIs, and there's integration with different front-end frameworks. This is the React flavor. We're pulling in the Neo4j GraphQL library, and we're pulling in Apollo Server Core and Apollo Server Micro. And these are specific flavors of Apollo Server that work well with the Next.js API routes feature that we're going to use. We're pulling in the GraphQL reference implementation micro, which is a web server that works well with Next.js. Neo4j JavaScript driver, and then Next, which is the React framework we're using, as well as React. So those are the only dependencies we have. And if we look at this index page, so we have a very basic welcome to Next.js page. Well, if we go to pages, index.js, we can see how that page is being generated. So you can see some JSX here, which kind of looks like HTML. If you're not familiar with React, we use this language called JSX, which is kind of like a mashup of JavaScript and HTML. It looks enough like HTML to, you can kind of think of it as that way. But here's the basic structure for this page. So we said that Next.js has file-based routing. So what that means is that anytime we create a file in this pages directory, we get a route at that name. So index.js is the default, but we also have one for articles. So actually, if we go localhost 3000/articles, we actually have a page for our articles. And a bunch of stuff happened. Some things went by in the console there. We'll come back to that. But if we look at localhost 3000/articles, we have a very simple list of headlines here. We can click on one of these and it takes us to the article. Okay, cool. So this is our very simple front end list of articles. If we look at articles.js, look at the code, you can see where this data is coming from. So we're using the use query. This is a React hook from Apollo client. So we're just importing that here. We're defining the query. So there's a GraphQL API somewhere. We haven't quite seen where that is. But this query should look familiar. This is very similar to the query we wrote earlier, where we're looking for the most recent articles, so sorting by published date, and then just grabbing the title, URL, and the date published. Then we have an articles component. So it's a React component. And here we're actually fetching data from the GraphQL API. So we're passing in this article query, so this GraphQL query. And the data, when it comes back, is going to be in this object called data. So we can then use JSX to, in our case, create a unordered list. And then we're going to map over the articles that came back from our GraphQL request and add a list item with the title and just a link to the URL for the article, which is what we have here. So that is our very basic articles page that's querying a GraphQL API. But where's that GraphQL API? Well, one thing that is really nice about Next.js, in addition to this file-based routing, is the API routes functionality. So in Pages API, we have two files, hello.js, let's look at that one, which is just returning a JSON object. So if I go localhost 3000/API/hello, I get this simple name John Doe object. And what's going on here is that any files that I define within Pages API will get picked up by Next.js as a new API route. And when we go to deploy this, we're going to use Vercel. And what will happen is our static assets for our React application will be deployed to Vercel's CDN, their content delivery network, and any API routes will be deployed as serverless functions. So we actually have the skeleton of a GraphQL endpoint here in Pages API. And you can take a look what's going on there. But first, let's make sure that this is actually giving us a GraphQL API. So I'm going to go localhost 3000/API/GraphQL, and we should see GraphQL Playground. Oops, hello, I want, oops, wrong tab. Not hello, I want GraphQL. And we should see our GraphQL Playground. There we go. So here's GraphQL Playground served locally. And this is very similar to the query that we were writing to populate our very simple articles page. So let's look at the code here. So we're pulling in Apollo server. We're pulling in this GraphQL Playground plugin. By default now, with the latest version of Apollo server, you'll get Apollo Studio, which is fine. I like to just keep this one consistent. So this is how you can optionally add GraphQL Playground. We're pulling in the Neo4j driver instance and the Neo4j GraphQL class. And then because this is a serverless function, these are just kind of globals to handle a cold start. But the same structure, very similar to what we created before, the code snippet we saw before, where we define our GraphQL type definitions that match to the data model in Neo4j. Note these relationship schema directives, and also the exclude directive, where we're excluding certain generated operations. So we're only generating the read operation. So we're going to end up with a read-only API. If we weren't excluding these, we would have mutation operations for creating, deleting, updating data. Those are our basic type definitions. We create a Neo4j driver instance, and this is where we're reading those environment variables to connect to our Neo4j Aura instance. So that's why we had to set those in the .env file. And then because this is a serverless function, we need to export a handler. And here's where we're checking if we've already defined Apollo server or not. If we haven't, then we create a new Apollo server instance. If we've already created it, then we return the handler from Apollo server. But what's really nice is now we have our GraphQL server code and our React application in the same Next.js application. So we can actually now deploy this using Vercel. So let's go ahead and take a look at that. So Vercel is actually the company that makes Next.js. So we know that it's going to be integrated quite nicely, but Vercel basically allows us to deploy front-end applications, but also things like edge handlers, serverless functions. Here we're using a Next.js app, but we can do this with lots of different types of projects like Svelte, Vue, and so on. We can hook in to GitHub. So what we're going to do is sign into Vercel. And again, we can use the free tier of Vercel. We're going to create a new project that is connected to the GitHub project that we just created. And we will deploy that application to Vercel, and we'll then talk to Neo4j Aura. So we're running out of time here. We've got 11 minutes left. So I'm going to go ahead and go through the steps here. So I'm going to go to vercel.com. When I'm already signed in, yeah, I have a legacy plan, but you can use the free plan to do that. I'm going to click on New Project. And because I've connected with GitHub, you can see my GitHub history, and I have a new repo that I created 22 minutes ago. So let's bring that in. So this is the GitHub repo that I created using our template. And for framework presets, this is going to be Next.js. And if we had our Next.js application in the root directory, it would auto detect this, but we have some other things like our data in there. So we're actually going to specify the root directory is this Next.js directory. And then I need to set some environment variables. So we have this .env.local file, and this I don't want to check into version control. I don't want to have my my secrets out there, and I may want to have a different Neo4j instance that my deployed application in Vercel is talking to versus the one for development. So these can be different, but I'm going to need to, in this case, point this at my Neo4j Aura instance. So this is going to need a Neo4j URI, which is this value. And I need a Neo4j user, which is going to be Neo4j. And I need a Neo4j password, which was randomly generated for us when we created our Aura instance. And I've set this debug environment variable for logging things generated by the Neo4j GraphQL library. We could have that in the logs, that might be nice. And then this is another environment variable I'm going to need just so that Next.js knows where to look for the GraphQL API. And that comes into play here in this underscore app.js file. And this is where we point Apollo client to the GraphQL API. And so that's where this environment variable is being read. So that's /API/GraphQL, since we're running it as part of our Next.js application. Okay, and if I type that in correctly, I'm going to hit deploy, and Vercel will now pull down my GitHub code and deploy the React application to Vercel's CDN. It will give me a unique URL, and it will deploy my API routes as serverless functions. So we'll have a serverless GraphQL endpoint that will be deployed as part of that. Now, while that's deploying, let's take a look at our GraphQL API application one more time. So here's the local version. And I ran this query. So this says find 10 articles and bring back the title, published, and the URL. And if I look in the logs here, I have a bunch of things logged by, in this case, the Neo4j GraphQL library. So because I set this environment variable here, this debug debug Neo4j GraphQL : that means that I want to enable verbose logging for the Neo4j GraphQL library so I can see kind of what's going on behind the scenes there. And basically what it says is that we have this incoming GraphQL request. Okay, 10 articles, give me title, published date, and the URL. And that request is translated into this Cypher query and is then executed against the database. If I add more complex operations, So maybe I also want the topics for each article. So as I add that, I can see now the generated query includes the traversal for the topics as well. So we can see that the generated database queries in Cypher match exactly what's requested by the GraphQL API. One thing, and this is the last exercise, which let's see if we can do really quick here, and then folks can maybe try this at home. But if we go back to Pages API GraphQL, so if you look at our GraphQL type definitions. So early on in the first part, when we were writing Cypher in Neo4j browser, we wrote a Cypher query that said, okay, assuming you have an article, how would I find similar articles? So what I want to do now is expose that functionality in our GraphQL API. So I'm going to add a field. Let's do it here on the article type. It's going to be similar, and this is going to give me article, one or more articles. And we're going to use the Cypher schema directive. It takes a single argument, which is statement. And we're going to use that query that we wrote earlier. I'm going to modify it just a little bit. So we're going to say match this. So in this case, where we're adding Cypher queries using the Cypher schema directive, this is a variable that's injected that refers to, in this case, the article that we're currently resolving. So to find similar articles, we want to find the article we're currently resolving, and then traverse out on the has topic relationship to topic nodes, and then find other articles that have the same topics. So we'll save that. And now if we go back to Playground, I think we need to refresh for it to pick up the new schema, but now we have the similar field, so we can run this query. So now for these articles, we're finding similar recommended articles. That's included here in the selection set. If we go back and look at the generated output, we can see that we're still generating a single Cypher query. The statement that we added in that Cypher schema directive is included, though, it's kind of like a subquery in the generated Cypher. So what that means is we're able to add custom logic using this Cypher schema directive and still generate a single database query, which is pretty neat. Now, if we check in on our Vercel project, we can see that, cool, I've deployed my application and it has its own URL here, full stack GraphQL workshop. If I go to /articles, I should see my list of articles. Oh, if I don't, maybe I did something wrong there. Let's look in the console. Do we have our GraphQL API? If I do /API/GraphQL. Oops, not articles, /API/GraphQL. Maybe I fat fingered one of my environment variables or something like that. We'll have to figure out what went wrong there. But one thing that's neat with Vercel is that I can now do a commit. We'll say add similar field and push that up. And now, because my GitHub project is connected to Vercel, it immediately picks up that, hey, there was a new commit to main, and we're going to rebuild and redeploy your project. If we did this as a pull request, there'd be a preview build with a unique URL just for that pull request, but that wouldn't be promoted to production. So super useful for sort of being able to deploy full stack applications with Vercel. Cool. So I think we covered most things. I know that the last little bit was a bit of a whirlwind, but I wanted to make sure we covered the Vercel bits and the GraphQL schema directive as well. So this was the last exercise, which we went through kind of quickly there. Cool. Well, we're out of time. I'll leave this up with a link to a few resources for continuing on. Definitely the slides have all of these. That's the first link. Code's on GitHub. And then I've linked a couple of pages for documentation for the Neo4j GraphQL library, as well as a more in-depth Graph Academy training for GraphQL. Those are good next steps as well.
Cool, super. Thank you very much, Will. And like you said, I guess if the end now was a little bit too quick, and obviously there seemed to be an error in somewhere we couldn't identify quickly now. Everything is in the slides, so the slides will share. Obviously, in the slides will be there's a link in the description on the video as well, so you can follow from there and click through there, and hopefully that will then clear it up. And as I said earlier, if you then still struggle, if you have any questions, the community is always open, so don't be shy and ask questions. Thank you for joining. If you have to jump off, totally understandable. Thank you for watching. Take care, everybody, and hope to see you soon. Like I said, the video and the slides will be shared with you. But maybe we can take a minute or two to answer one more question. I think because it's an interesting one. It came in via chat. Is the articles and the recommendation? Does that similar step also include the article itself, or how does it take it in terms of a recommendation mechanism?
Yeah, that's a good question. So if we look at the query, so this is the query that we added, and we said that this is a special variable that references the article that we're currently resolving, right? So I think the example that we had was, I don't know, it's the New York City COVID article. And then we're going to traverse to topic nodes. And then, so maybe we have 3 topic nodes, and then we're going to traverse out to find other articles connected to the same topic. And there's an important characteristic of Cypher here, which is that when we define these patterns in Cypher, we only follow a relationship once. So we're going to follow this outgoing has topic relationship from the article we're currently resolving. And then because those are going to be, and we may have multiple relationships here, right? We may have like multiple topics connected to this article. But then on this part of the traversal, when we're following incoming has topic relationships to our topic nodes, we're not going to follow any of the has topic relationships back to our original article because we've already traversed those. We've already traversed the relationships connecting the article we're currently resolving to all the topics. We've traversed that in this part of the query. And that's just a convention with Cypher that we only traverse those relationships in the pattern once. So in this case, rec is never going to be the currently resolved article. We're always going to get different articles because we're not traversing the has topic relationship back again since we've already did them once. Hopefully that makes sense.
Yeah, I think that does make sense, and that's a good. I mean, you don't want to get a recommend. I mean, if you look for a recommendation from something, you don't want to get the same article as a recommendation, because you kind of already know that article or that item, whatever you're getting a recommendation for. So that's not going to be any worth to to anybody
Yeah,
if it's that the case.
exactly. Yeah, and there's a graph term called a cycle, which is basically like if you follow relationships that kind of lead back to the original node, you can have a cycle. And if Cypher was just following every relationship multiple times, you'd end up with a cycle, and kind of wouldn't be clear where that would terminate. So that's a feature of Cypher that allows you to not really have to think about getting stuck in these cycles as you're writing these queries.
Super. Okay. I think that brings us to the end of this session. Thank you, Will, for taking us through GraphQL and the tutorial or the workshop for today. If you're interested in doing another workshop, we are doing one more this month with Claire Sullivan next Wednesday, actually, on data science. So if you wanna join that session, register for that now. That's gonna take place next Wednesday, so a week from now. Um, Other than that, yeah, thank you for watching. Hope you stay safe. Take care, everybody. And yeah, see you soon at another live stream or another webinar from Neo4j. Until then, bye bye.